In the last video, we were looking at finding the rule using a table of values. So in this video, we'll look at how to find the rule when the coordinates are provided in different ways, both as ordered pairs or from a linear graph. So firstly, let's look at some ordered pairs. So to work out the rule, you've got to remember that the first coordinate is the x and the second is the y. And so again, we want to find what is the pattern, what operation has been performed to the x to get to the y value. So pause the video, have a look at these coordinates and see if you can work out a pattern, a connection between the x and the y. So you might have noticed we're going from 0 to 3, so that's plus 3, from 1 to 4, so 3 is being added, 2 to 5, plus 3, and so on. So the rule would be y equals x plus 3. So substitute, check a few of those. If x is 4, 4 plus 3 is 7, gives us the y. 3 plus 3 is 6. So this rule works. Now this one is a little bit trickier. So again, pause the video, see if you can work out a pattern, a connection between our x and our y coordinates. Okay, so you might have noticed that we can multiply by 2 here. So we're going from 3 to 6. So we multiply by 2, 2 to 4. 2 times 2 is 4. 1 times 2 is 2. So we could say the rule might be y equals 2x. So we've got to multiply by 2. But it's not just multiplying by 2. We're multiplying by 2, but then the sign is also changing. So we're actually multiplying not by positive 2, but by negative 2. So the rule is y equals negative 2x. So if we substitute and see whether that works, if x equals 3, negative 2 times 3 is negative 6. If we substitute x equals negative 1, negative 2 times negative 1 gives positive 2. So our rule is y equals negative 2x. Okay, so now we'll look at some examples where we have a linear graph and we've got to work out the rule. So to do that, we need to pick a few points on our graph. So let's say this point here, that's at x equals 0, y is negative 2. So there's one coordinate. What about this one? X equals 2, y equals 0. We could take this point, x equals 3, y equals 1. We could try this point here, x equals 5, y equals 3. So that should be enough points for us to work out the rule. Like we did before, we need to look at our coordinates and work out the connection between the x and the y. So have a look at these coordinates, pause the video if you want, see if you can work out what it is. So in each case, it's going down by 2, 3 to 1, 5 to 3. So we always need to subtract 2 from our x value. So the rule would be y equals x minus 2. Okay, last one. So again, we need to find some coordinates to use to work out the rule. So we'll say this point, which is at x equals negative 2, y equals 8. We could take this one. So x is -1, y is 4. We could take the origin, 0, 0. We've also got this point here. X is 1, y is -4. And why don't we take one more? X is 2, y is -8. Okay, so pause the video, see if you can work out what the connection is between our coordinates. So we can't add or subtract a common amount. See, 2 minus 10 would be -8, but then 1 minus 10 would be -9, not -4. So it's not adding or subtracting. So if we try multiplying or dividing, 2 we could multiply by -4 to go to -8. And if we multiply by -4, again, 1 times -4 gives us -4. 0 times -4 will give us 0. -1 times -4 will give us +4. So our rule must be y equals -4x. If it goes through the origin, that's a good clue that the operation must be multiplying and dividing, and there's been nothing added or subtracted, because if we multiply or divide anything by 0, we'll still end up with 0. Another clue to the rule is if you actually look at the graph and think back to the last unit when we were talking about gradients, a graph sloping downhill like this, we said is a negative gradient. And you see in our rule, our coefficient is a negative. So when the graph is like this, sloping down, you know that the coefficient will be negative. And if the graph is sloping up, the coefficient will be positive.